This is section 5.7.2, geometric sequences. We're going to start with the definition of a geometric sequence. It is a sequence in which each term after the first is obtained by multiplying the preceding term by a fixed non-zero constant. The definition of common ratio. It is the amount by which we multiply each term to get the next. So in the definition of geometric sequence, the fixed non-zero constant that they're referring to is the common ratio. A sub 0 is called the initial term. We already know from arithmetic sequences that a sub 1 is the first term of a sequence. A sub n is the general term of the sequence. And now R is known as the common ratio. The recursive routine for a geometric sequence is a sub n equals a sub n minus 1 times R. You remember, same as with arithmetic sequences, that the recursive routine simply describes what a geometric sequence is. And it does this by saying that if you're going to find a term of a geometric sequence, you take the term before it, that's why it's n minus 1, and you multiply by the common ratio. In our first example, we are being asked to write the first 6 terms of the geometric sequence with first term 6 and common ratio 1/3. In this case, we would take 6, multiply by 1/3, get 6 over 3, which is 2. Then we would take 2 and multiply by 1/3 and get 2/3. Then 2 times 1/3 is 2/9, and so on, getting 2 over 27 and 2 over 81 to round out the first 6 terms of this geometric sequence. Write the first 6 terms of the geometric sequence with first term 12 and common ratio -1/2. So we're going to multiply 12 times -1/2 and get -6. Then -6 times -1/2 will give us +3. Then +3 times -1/2 will give us -3/2. And we continue multiplying by -1/2 to get 3/4 and -3/8 for the first 6 terms of this sequence. Next, we're given a series of sequences in which we are being asked to find the common ratio. We can find the common ratio of any geometric sequence simply by taking one term and dividing it by the previous term. So, for example, in our first sequence, we could do 5 divided by 1 and get 5, or 25 divided by 5 and get 5, or 125 divided by 25 and get 5. By doing a few of these, we can see the consistency. In each of those division problems, we're getting 5, so that tells us that the common ratio R equals 5. In our second sequence, 8 divided by 4 is 2, 16 divided by 8 is 2, 32 divided by 16 is 2, 64 divided by 32 is 2. In the third one, -12 divided by 6 is -2, 24 divided by -12 is -2, and so on. And finally, in the last sequence, -3 divided by 9 is -1/3. 1 divided by -3 is also -1/3. All right, next we're going to talk about the general term of the geometric sequence. Consider the sequence whose first term is a sub 1 and common ratio is r. So there was a similar slide in the video about arithmetic sequences. So what I'm showing you here is that the first term is the first term. But to get the second term of the sequence, we're going to take the first term and multiply it by the common ratio one time. To get the third term, we're going to take the first term and multiply by the common ratio twice. Now, don't be confused. This is not a sub 1 times 2r, because if we did a sub 1 times r twice, it would look like this. And of course, r times r is r squared. Continuing this pattern, to get the fourth term of the sequence, we would take the first term and multiply by the common ratio 3 times. The fifth term, we would take the first term and multiply by the common ratio 4 times. And as you can see the pattern, we're always multiplying by the common ratio one less time than the term we are trying to find. Therefore, a sub n, the general term of a geometric sequence, is a sub 1 times r to the n minus 1 power. Here we have two examples. Let's take a look at the first one. Find the 28th term of the geometric sequence, whose first term is negative 4 and whose common ratio is negative 2. Okay, so we want to find the 28th term. That's a specific term, a sub 28. Using the formula for the general term, we're going to take the first term, a sub 1, and we're going to multiply it by the common ratio 20 set to the 27th power, because remember, n minus 1, 28 minus 1 would be 27. So the 28th term, plug in our first term, which they told us was negative 4. We're going to multiply that by the common ratio of negative 2 raised to the 27th power. Plugging this into your calculator, you can see that the 28th term of the sequence comes out to be the following. $536,870,912. All right, let's look at the second example. Find the 57th term of the geometric sequence whose first term is 5 and whose common ratio is negative 3. All right, so once again, we're going to start out by using our formula. We want the 57th term, so that's a sub 57. Plug in the first term, which they told us was 5, multiplied by the common ratio, which is negative 3, raised to the n minus 1 power. 57 minus 1 is 56. When you plug this into your calculator, you're going to get a very large number. Make sure that you recognize this as a large number, because your calculator is going to make it look like this, 2.6167. There's going to be a whole lot of numbers, and at the very end it's going to say e to the 27th. Now you should know from our talk of scientific notation that this is how the calculator represents scientific notation, and when written correctly, we would write this as 2.6, I'm just going to round it to the 10th place, times 10 to the 27th power. That is a very large number. All right, in the next example, it says, write the formula for the general term for the geometric sequence. Then use the formula to find the 8th term. Okay, so looking at the sequence that they give us here, we need to determine first what a sub 1 is. We can see that pretty clearly. 3 is the first term of the sequence. And the common ratio, well, remember 6 divided by 3 is 2, 12 divided by 6 is 2, 24 divided by 12 is 2. Common ratio is 2. So using the general term, we know our formula, a sub n equals a sub 1 times r to the n minus 1. The general term, we're going to leave that a sub n. We're going to plug in our first term. We're going to multiply it by 2 to the n minus 1 power. So when they ask us for a formula, this is our formula for the sequence that is given right here. This is our general term formula. Now in the second part it says then use this formula to find the 8th term. Okay, well now since we're finding the 8th term, we know that n equals 8. 3 times 2 raised to the 8 minus 1, which is 7th power. Plug this into your calculator, and you get 384 for the 8th term of the sequence. So that's a look at a couple different examples on using the formula for the general term a sub n and how you can use that formula to find a specific term of a geometric sequence. This has been section 5.7.2 on geometric sequences.